Well, hello again, and this is part 3 of our exploration into the mole. And so far, what we've learned is a definition for the mole. We said what? The mole is Avogadro's number of particles. And then we started talking about some calculations that we do with the mole, right? We said, hey, I can go from moles to particles, and how do I do that? I multiply by Avogadro's number. I can go from particles to moles, and how do I do that? I divide by Avogadro's number. I can go from grams to moles, and how do I do that? I divide by molar mass. And we've calculated molar mass. We said, hey, molar mass is the mass of one mole, and that can be for an element or a compound. And that's about where we are. And let us consider this. I have 1,472 grams of barium chloride. What is the molar mass of barium chloride? How many moles of barium chloride are there? So we have barium chloride, right? And so the molar mass of barium chloride is going to be 1 times the molar mass of barium plus 2 times the molar mass of chlorine, right? Oops, molar mass of chlorine, that's pretty. There we go. Good. And so when we looked that up, what did we say? We said, whoops, 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 whoops. Where's my periodic table? Zoink, here's my periodic table. Where's my barium? It looks like 137.32, 137.32, 137.32, 137.32, plus 2 times my chlorine. Where's my chlorine? Na 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 na. Chlorine, right here, 35.45, 35.45. 35.45, and that's in grams per mole. And so what do I get here? Use my magic calculator, and I have what? 35.45 times 2 plus 137.32, and that looks to me like a 208.22 grams per mole of my barium chloride, right? So that's my molar mass of barium chloride. So how many moles? Okay, how do I get moles? And what do I start with? Grams. I go from grams to moles. That means I'm going to divide by what? Molar mass. Now, that's the equation approach. I use dimensional analysis, meaning what? I know that 1 mole of barium chloride equals what? Well, 208.22 grams of barium chloride, right? That's my equality. And then I have 1472 grams, 1472 grams of barium chloride. I'm going to multiply that by a fraction. I'm going to put in the denominator what I want to get rid of. I want to get rid of grams of barium chloride. So I'm going to put 208.22 grams of barium chloride in the bottom, and that's equal to what? 1 mole of barium chloride on top. My barium chlorides cancel, and what do I get? Okay, 1472 divided by 208.22, and I get 7.069. I have 4 sig figs here. That means I can only have 4 sig figs here of what? Moles of barium chloride. There we go. Cool. Excellent. Now, here we go. You guys try this one. You have 83.5 grams of oxygen gas. How many moles of oxygen gas are there? I'll tell you that there's a trick here. Be careful. Bring me back when you're ready. Well, the trick is what? I have oxygen. Oxygen here as a molecule or a diatomic molecule, meaning it is O2. Aha. So then what is the molar mass of O2? Well, it's going to be 2 times the molar mass of 1 oxygen, which is 2 times 16.00, which is 32.00 grams per mole of O2. Good. What do we start with? I start with 83.5 grams. And what is it that I want? I want what? Moles. So I want moles of oxygen, moles of O2. Start with 83.5 grams of O2 times what? Well, I have 1 mole of O2 over 32.00 grams of O2, right? And so what do I get? 83.5 divided by 32, and I think that is 2.609. 2.6, uh-oh, I only have 3 sig figs, so 2.61 moles of O2. There we go, right? And if you worked that a different way, you could do what? Going from grams to moles, what do I have to do? Divide by molar mass. So you take your grams, my grams, 83.5 grams of O2 divided by 32.00 grams per mole of O2, and you'll get the same answer. Cool. All right, you guys give this one a shot. Bring me back when you're ready. Okay, this is not difficult, is it? I'm going from grams to moles. Okay, I'm going to go from grams to moles. How do I do that? I have to divide by molar mass. That means I need to get the molar mass of iron 2 sulfide. If it's iron 2, sulfate, sorry. If it's iron 2, that means it's Fe2 plus. What is sulfate? SO4 2 minus. So that means I have FeSO4. And how do I get the molar mass of that? That's going to be equal to the molar mass of my iron plus the molar mass of 1 sulfur plus 4 times the molar mass of oxygen. Good. So let's go to our periodic table. Where's my iron? Iron 55.845 we'll go with. 55.84. We can go with 55.84, I think, here. 55.84. 55.84. Plus, what's my molar mass of sulfur? Oops. I guess 55.85 I should do. Sorry, I should round that, shouldn't I? 55.85, because we're only going with 2 decimals. What about my sulfur? Sulfur is what? Looks like 32.07. 32.07. Wrong one. 32.07. 32.07 plus 4 times, hey, I have oxygen memorized, 16 grams per mole. Let's add this up. 55.85 plus 32.07 plus 64. And I get 151.92 grams per mole of iron 2 sulfate. Got it? I hope I did that right. 4 times 16, 64. Yeah, I did that right. Plus 32.07 plus 55.85. It looks like good. Right. This is my molar mass, right? But I don't want molar mass. I want moles. So I have what? 7.201 times 10 to the minus 2 grams times what? 1 mole of iron sulfate per what? 151.92 grams of iron 2 sulfate. So I'm going to take my 151.92, invert times 7.201 times 10 to the minus 2. And it looks to me like I get a really small number. How about 4.7? How many sig figs? 4. 4.7399740 times 10 to the minus 4 moles of iron 2 sulfate. 1, 2, 3, 4. That looks good. 4.740 times 10 to the minus 4 moles of iron 2 sulfate. You might have a slightly different number if you rounded differently, or if you chose a different set of numbers from the periodic table, or you have a different periodic table. Good. Did we answer that? Oops. Did we answer that? Yes, I think we did. Last one. You guys do this one. Consider nickel 2 carbonate. How many moles of nickel 2 carbonate are there? Bring me back when you're ready. Once again, I'm going from grams to moles. So grams to moles, what do I need to do? I need to divide by molar mass. I need to figure out the molar mass of nickel 2 carbonate. Nickel 2, that means it's Ni2 plus. Carbonate is CO3 2 minus. Oh, that's easy. Too easy, Mr. Smith. You're right. It'll never be this easy on a test. So that means what? I need 1 molar mass of nickel plus 1 molar mass of carbon plus 3 times the molar mass of oxygen. So let's look at nickel. Nickel, where's nickel? Looks like it's 58.69. 58.69. 58.69 plus carbon. I think carbon's 12.01. Let's see, where's carbon? 12.01. Hey, I've got that one memorized. 12.01 and 3 times oxygen. We all know oxygen now is 16.00. Let's add this all up. 3 times 16 is 48 plus 12.01 plus 58.69. That looks like 118.70 grams per mole for nickel 2 carbonate, right? Let's just work this not the dimensional analysis way. Grams per mole. How do I go from grams to moles? Moles are equal to what? Grams divided by molar mass. What are my grams? 1.53 times 10 to the minus 3 grams divided by the molar mass, 118.70 grams per mole. And I get what? Okay, invert that times 1.53 times 10 to the minus third. And it looks to me like I get 1.2, how many 3 sig figs? 1.29 times 10 to the minus 1, 2, 3, 4, 5. 10 to the minus 5 moles of nickel 2 carbonate. And if you prefer the dimensional analysis route, we do what? 1.53 times 10 to the minus third grams times what? 1 mole of nickel 2 carbonate over 118.70 grams of nickel 2 carbonate. And we get the same number. All right? 1.53 times 10 to the minus third divided by 118.7. Yes. All right. Cool. Where are we? Can we go farther? Yeah, we can go farther. Good. Let us jump into our last section. I have 17.98 grams of chlorine gas. How many molecules? Aha, we're going from grams to molecules. How do I go from grams to molecules? Well, let's go back and we add another equation here. I want to go from grams to particles, right? Molecules are particles. Particles. Can we go directly from grams to particles? No, I can go from grams to moles, and then I can go from moles to particles, and that's exactly what we do. We're going to go from grams to moles. What do I do to go from grams to moles? We divide by molar mass. And then how do I go from moles to particles? Well, to go from moles to particles, what do I do? Moles to particles, I multiply by AVO. There we go. So this is the way that we can go from grams to particles. Grams to moles, step 1. Moles to particles, step 2. All right. I have chlorine gas. Ooh, chlorine gas. Well, chlorine as a molecule, it's diatomic. Remember, it's ClO2. So I need to figure out my molar mass. So my molar mass of Cl2 is equal to 2 times the molar mass of Cl, which is equal to 2 times my chlorine is what, 35 point what? We should know that now. It is chlorine. Oops, can't see it. Abracadabra. Yay. 35.45. Okay, 35.45. 35.45. 35.45. And that looks to me like that's 70.90 grams per mole, right? Good. So that's my molar mass of chlorine. So I want to go from grams to moles, and then from moles to molecules, right? Okay, so I know that 1 mole of Cl2, chlorine, is equal to 70.90 grams of chlorine. And I know what? 1 mole of chlorine also equals what? 6.022 times 10 to the 23rd molecules of chlorine. Cool. So now let's put this all together. We're going to do it the dimensional analysis way. 17.92 grams of chlorine times what? Well, 1 mole of chlorine over 70.90 grams of chlorine times what? Well, I want to get rid of, see, that gets rid of grams, right? Good, but I want to end up with molecules, so that means I want 6.022 times 10 to the 23rd molecules of chlorine over what? 1 mole of chlorine. And let's see if my units work. My grams canceled, my moles cancel. What am I left with? Molecules. Excellent. So now I just have to multiply this all out. 17.92 divided by 70.9 times 6.022 times 10 to the 23rd. And how about 1.5 now, sig figs? I've got 4 sig figs. 1.522 times 10 to the 23rd molecules of chlorine. Now we have to remember, what was the key here? We have to remember our diatomic, right? My diatomic molecules, if they say chlorine gas, remember it's chlorine and fluorine and oxygen and nitrogen and hydrogen and bromine and iodine, right? These are my diatomics. So if they say, hey, you have bromine or you have nitrogen, that means it's going to be N2 or Br2. Cool. You guys give this one a try. Bring me back when you're ready. Ethane. Okay, remember ethane. Ethane means I have 2 carbons, and ane means they're all saturated. That means each of these carbons there's a single bond between my carbons, and we have my hydrogens, right? Something like this, and you can always draw the picture, or we could remember what? CnH 2n plus 2. So if n is equal to 2, then H is 2, 4, 6, H6. So that's my formula for ethane. Good. Grams to molecules. That means I have to go from grams to moles, and then moles to molecules. Good. I can go from moles to molecules, right? 1 mole of ethane, C2H6, is easy. 6.022 times 10 to the 23rd molecules of ethane. But what's my relationship between 1 mole and grams, right? Well, that is my molar mass, right? So I need to get my molar mass of ethane, C2H6. So that means I need 2 times the molar mass of carbon plus 6 times the molar mass of hydrogen, right? And 2 times 12.01, hey, I've got that memorized, plus 6 times, oops, I don't have hydrogen memorized. Well, I really do, but let's look it up anyway. Here's my hydrogen, 1.008. That's what I use, 1.008. Okay, 1.008. 1.008. 1.008 grams per mole. Good. Here we go. You ready? 6 times 1.008 plus 2 times 12.01, and that looks to me like it is 30.068 grams per mole of ethane. Cool. All right. You ready to work this all out? What do I start with? 0.984, 0.984, 0.984 grams of ethane. And I want to convert that to moles, so I'm going to do what? There's 1 mole of ethane per its molar mass, 30.068 grams of ethane. Okay, good. So my grams cancel, and I'm left with moles, but I don't want moles. What is it that I want? I want molecules. So then we say what? I have 6.022 times 10 to the 23rd molecules of ethane over 1 mole of ethane. Yeah, good. Now we just run the numbers because look at my moles of ethane cancel. What am I left with? Molecules, and that's exactly what I'm looking for. Here we go. 0.984 divided by 30.068 times 6.022 times 10 to the 23rd. And abracadabra, I get 1.97. There's only 3 sig figs here, so I can only have 3 sig figs here. Times 10 to the 22nd molecules of ethane. There we go. That's wonderful, folks. Okay, I think we've probably pushed this about as far as we want to today. Let's finish this off today, and next time we will finish off our discussion of the mole. Ciao.